Hey class. So today we will be reviewing and going into further detail on how to use Dynamo, how to integrate it within the Revit process, our building process. And today we'll be focusing primarily on developing a form within Dynamo, not from Revit, but within Dynamo, and being able to manipulate that, develop it, structure it, develop drawings from it, etc. So um, we'll be just creating a new file, just like we always do with our template, and then opening up Dynamo from the Manage tab. And we can, once it starts, we can go into a 3D view. All right, and then just starting a new Dynamo session. All right, and so what we're going to start off doing is we're going to create a tower that we can control the number of levels of, we can control the height of the levels, and then we can also start to play with the geometry of that tower. So it's a pretty prevalent example, but a rotating tower, right? Something that we can manipulate, control the rotation of, and twist and turn and control the geometry of as we go up. So what we want to start off by doing is going in and getting an integer. Actually, we can just do a number slider. Grabbing a number slider. And if you double click on the name, it'll pop up with an edit node name. And we can call this number of levels. All right, and then, we don't want a 30 level tower is pretty good. And then step, we want to change to a whole number because you can have half levels, I guess, if you won't have mezzanines or whatnot. But for what we're doing now, we'll just create a whole number. So this is from 0 to 30, stepping up by 1. And then copy and paste this. And create a floor height controller. And then this, if we're using feet, 15 is a pretty standard height. And realistically, we're probably not going to go below 9 feet. So we'll use that. All right, and then from here, what we want to do is create a series of points. These will be the origin points for the levels that we'll be creating. And so really simply, we'll just grab a point by coordinates. So it's asking for an X, Y, Z. And I got into the code block a little bit last class. If you double click with your left mouse button, it will pop up with a code block, and you can pretty much type in whatever you want. You can write lines of code if you want, or you can just use it as really general number inputs. So if you type in 0 and then a semicolon, remember anything you type into the code block must be ended with a semicolon to tell the code block that you're finished writing in it and you want that to be an output. So 0, we can type into the X and Y. And then the Z is going to be influenced by our number of levels and our floor height. And we're going to use the code block a little bit differently now to generate that. So if we double click in here, like I said, you can write code, and there is a whole forum on the Autodesk Dynamo website that you can go into to explain exactly what the different methods are to develop and create these scripts. So a really simple one is creating a sequence block, and to do that, actually here, let me show you the actual, essentially the actual node that we'll be coding. So if we type in sequence, right? So it's asking for first a start, then the amount, and then the amount that you want to step, right? So we want to start at 0. So all you got to do, type in 0 into your code block. Then hit 2 periods. That signifies that you're going to a new value. Then what you want to do is hit the hashtag button and levels. Okay, this is going to ask for an input. Okay, so when you type out a word like this with the dot dot between it, it's going to create an input called levels at the beginning. And whatever input is put into levels, the hashtag signifies the an amount. So I'll show you what it does with the hashtag, the pound key, I guess, and what it does without. So we'll do levels, and we'll plug in the level slider into that input once it's created. And then we'll do another dot dot and floor height. All right, so that's going to ask for our floor height. And notice we didn't put in a pound key or hashtag. And that is because it's asking, it can only ask for one series of numbers. So hit your semicolon to finish the line of code and click. And then it's giving us an error. Levels. All right, so that's because we don't have any inputs yet. So if we input our levels into the levels input, just create it here, and then floor height. Then if we hover over and do the drop down, you can see that we start at the value 0, then we increase by the floor height. So if we decrease, right? So it's different. So we increase 12 times, 0 to 11, 12 times, by 11, the numeric value of 11. So 11, 22, 33, etc. Right? If we get rid of the hashtag, essentially what this does, right, is now it's saying that you want a list from 0 to 12 increasing by 11, right? You want a list from 0 to levels that are increasing by the floor height, right? So if we increase this, every time it increases by a value of 11, it adds a value to the list. And if we increase the max by, to 100, you can see every time we increase the end value that we're shooting at by 11, we add a value to the list. All right. Now what the hashtag does is it tells the code instead of being the list from 0 to levels and adding the values of the floor height in there, it's saying that we want a list starting at 0 and increasing by the floor height this many times, right? So we want the 18 values in this list starting at 0 and increasing by the floor height. I know that's kind of confusing, but this is an introduction to coding. I'm not going to lie to you guys. I'm not the best coder. However, like I said, there is a primer or a whole forum tutorial that goes through, start to finish, how to set up these codes and how to use it. And they can be extremely valuable, as we'll see moving forward through the rest of the tutorial. But what we're going to do, right, so this has a list, and this is what we want, right? We want 12 levels, increasing by 11, and starting at 0, which is what this list gives us. So what we'll do is plug that into the Z, and if we go, and I know the guys, or girls, all of y'all who don't have the 3D view, I apologize. I really don't understand from a computation standpoint why that takes so much more memory than Revit does, but unfortunately that's just how what we got to do to move forward. So from here, now we have these series of points that are completely adjustable. We can add to the amount of levels in the tower, and we can also adjust the heights of the levels. All right, so now what we need is we need a floor line, essentially cross section, to start to manipulate and control and create the geometry of the tower itself. And we'll use an ellipse to do that because it gives us a little bit more interesting of a form, and I think personally is a little bit more elegant than, you know, say a rectangle or another form of geometry. And obviously a circle, if it rotates, it's not going to look very different. So we'll use the by origin and radius. So this is asking for the origin point, which is our points. And then it's also asking for the radius of the x and y axes of the ellipse, because the ellipse obviously has two radiuses, otherwise it would be a circle. So we want to copy and paste some of the number sliders down, change the name of the one to, let's say x radius, and we'll change that. Yeah, that's fine, I guess. And then we'll copy and paste this guy down and just change the name of this one to y radius. That's 7. Y radius. Plug those guys in, and then we can start to adjust them. Ooh, funky. All right. So now we have a series of the ellipses that we can control the spacing of and the geometry of. And what we need to do after that is we want to twist this tower, right? So we want to have this tower twist and rotate, which means we need to rotate these ellipses, and then we'll loft them all together to create the geometry. So first we want to hit a geometry rotate. And of course, you know, why would geometry rotate pull up the geometry rotate? All right, so we want origin. So we want input to be geometry. There we go. So rotate, geometry, origin, axis, and degrees. And then our ellipse will be our geometry. The origin will be our points. The axes will be the z-axis. So you can actually find that just like you can in that's coordinate system. Let's see, vector. Yep. Just like you can in Grasshopper, you can find the world z-axis. Plug that guy in, and then finally, what we need is a rotational value, an angle of rotation, and you know, we obviously don't want all of these to rotate at the same time, because otherwise it'll just be a straight geometry. It won't have any twisting values. So what we can do is copy and paste again those sliders and change. Well, we can change the number to, let's see, bottom floor rotation. And then this one to the top floor rotation. All right. And then the top floor rotation will change to like 400. So we have a real large spectrum to rotate. And then we're going to use a code block again. All right. So this time, what we're going to do, instead of using 0 as our base value, for the list that we're creating, what we want is the bottom value, that bottom floor rotation value. So we'll just type in a general name, bottom. That'll be the name of the input. These names have no bearing on what the block does. You could name it giraffe, you could name it Bjarkingle, like you can name it literally anything. It's just the name that's going to be put on the input once we finish the code block. So we'll do bottom, period, period, dot, period, period, and then we'll use the # levels. And make sure you do levels with an S, plural, not level, because in the code block, certain names have certain values, right? So level is an actual node, an actual command node that lives within Dynamo that you can reference and utilize within your script, but that won't generate an input. That will actually utilize the whatever command you're in. And so you can see that if you just type in level, it has the command pop up. And then if you just left it that way, it's not going to work. It's going to error out because you didn't use the level command in the proper way. So we want to make sure we add that S to the end. All right, and what this does, so it populates a bottom, top, and levels input on the right-hand side. It's going to ask for a list from the bottom value, which is 9, to the top value, which is at the moment 14. And then what this does at the hashtag at the end, it's asking for a list from the bottom value to the top value, evenly divided by the value that we input into levels, right? So if we drag in levels, let me look at this list. So what it does is it takes the bottom value 9 and the top value 14. It puts it in the bottom of the list and the top of the list, and then dependent on what the value of levels is, it will create a list that long and basically divide the values between the top and bottom value evenly along the number of values within the list, right? So if we change this to 331, it's going to divide that evenly across 9 levels. If we change the number of levels, it's going to increase the size of the list, thereby increasing the size of the values that they have to divide evenly along the list. Slow that back down. Right? If we get rid of the #, now it's just creating a list from 0 to 331 as many times as it can increase by 13. So it's the same kind of idea as here when we took out the hashtag from the levels up here. It changes the structure of the list and how the code block is actually reading the values. So now that we have that, so that's what we essentially want. We want this the ellipses to start at the bottom floor rotation angle. Realistically, it can be at 0. That's perfectly fine. And then we want to specify the top floor rotation, and then we want each corresponding level to rotate evenly. So as the form moves up, it gradually rotates out. There's multiple ways to do that. This is just one way, showing you kind of the makeup of the code block. You can also do a code where you just specify the bottom rotation, and then you want it to increase by, let's say, 15 degrees every step. That'll do the same thing. You could also manually do this code block by specifying the total, the top floor rotation and bottom floor rotation. You could take the top floor, subtract it by the bottom floor, and then divide it by the amount of levels that you have, and then tell the script to increase a certain amount of steps by that value, that divided value. You get the same way. As I'm saying, in mathematics, at times there are plenty of different ways to get to the same series of numbers, so I'm just showing you one way. Anyway, after that ridiculously long and probably unnecessary explanation, you can take that and plug it into the degrees. Of course, right now the two ellipses are overlapping, so we'll want to unpreview the original axis rotation, or excuse me, the original ellipse. And then what we can do is we can start to visualize how those rotations work. Kind of cool. All right. So now that we have that, what we'll want to do is we can actually loft all these cross sections together. These what will ultimately be floor levels. We can loft them together to create a perimeter surface. So poly surface. All right, and then this is essentially just a loft command, just like you would have in Rhino, that's asking for a series of cross sections. And the nice thing about this is it's already in order, so we don't have to worry about the curves lofting in the incorrect order. And then that gives us a nice geometry, which you can see in your Revit browser. Now, for those of you who don't have the 3D preview, I don't know this for sure, but I did remember that there is a Watch 3D display that essentially duplicates the 3D environment here. And what you can do with it is you can plug in a specific component to the Watch 3D, and it will preview that specific component. It won't preview the entire list like the full scale 3D preview is, but it will preview the geometry or whatever node you've put in. So like if we just plugged in the cross sections, it'll just show us the cross sections. I don't know if that'll work if you don't have the 3D preview behind you. I don't know if that will actually work or not, but it might be a good thing to try. I apologize in advance if it crashes your computer. So now, what can I do with this? Well, I mean, I can try and bake it and use it as a conceptual mass. But that's kind of ultimately what this geometry is going to allow us to do. We can push this a little bit further to start to really develop and create Revit elements from this, and actually start to set up our Revit project based around this. And since it is fully parametric, be able to manipulate and adjust certain parameters. And have the Revit project and the elements that we attribute to this geometry live update as well. So the first thing that we can do is pretty simple, right? We can take the outlines that we've created that generate the form and use those outlines to create floors. So if you go into your Revit group under the drop down, you can go down to elements, all right, and then it brings up all the different element types that you can create and control in Dynamo from the Revit project. And floor is one of them. And you can do a couple. You can do outline curves and just an outline. So what we'll want to do, you would think that you would be able to generate this by a curve, right? However, as we saw like last time when we were trying to build our structures, and some of the curves were coming in as two individual curves and some were coming in as one whole one, That's the same with ellipses. The ellipses are, in their essence, two separate curves because they have different radius and different curvature. So what we want to do is use the outline by curves, all right? And instead of just plugging the geometry into here, what we want to do is actually explode that, or split it, excuse me, so to make sure that the curves are readable and consistent as we go up. It's a weird thing with Dynamo. One of the other reasons why I don't like it, in which you kind of have to break the curvature geometry down into its base form for the component to read. So what we got to do is split by parameter. It's down here, split by parameter. And this parameter is asking for a value between 0 and 1. So we can just split it into 2 by just typing in 0.5. Now, I'm going to bring this up real quick. If you just type in 0.5, it's going to error out. All right. If you're ever trying to just really quickly type in a decimal value into a code block, you must make sure you hit a 0 beforehand. Just way Dynamo reads it. All right. Plug that in. What that does is it takes all the curve geometry and it breaks it into 2. And then we can plug that into our outline curves. Now you can try and just bring in the one geometry, that's fine, but trust me, it's not going to work. And if it does work, then good for you. All right, so the other two things, the other two inputs that this floor by outline is asking for is the floor type. So what is the family type that the floor is going to be? Is it going to be lightweight concrete? Is it going to be your generic 12-inch? It depends on what is imported into your Revit project currently, the one that it's pointing to. So the Dynamo has a floor type specifically that you can plug in and use as a selection tool. So this brings in all the different floor types that are loaded onto your project right now. So we'll just use a really simple, let's use a lightweight concrete on metal deck. Sounds pretty specific. So we can plug that into our floor type. And then the last thing it asks for is a level. Now, you have levels that exist in your project right now. You have your level 1, 2, and roof. Those are fine. And you could go in and create however many levels we have in here and set them at the elevation that we've already specified. But that's not very parametric because you'll have to go in, if you edit any of these values, you'll have to go in and edit those manually. And so what Dynamo allows you to do is build those levels using the data and the values that you have already created within your script to tie and create those levels back to the parameters you have set. So to do that, we can go into Revit, again, go down to Elements and scroll down to Level. And then what this is, there's a couple different ways that you can do it. You can do by elevation, and this will just give it a name of whatever. Like if you just copy and pasted your levels right now, it would kind of just automatically give you a name. Same thing here. By elevation and name, this is what we'll actually use. You can click that. And then, by level and offset, these are all different generation tools that you can use. But we'll use the elevation and name. So this is asking for specific elevation, and it's also asking for a name. So you could do, 30 and level 3, and it will pop out a level and generate a level at 30 feet named level 3, whatever I just said. But we want to make this parametric and we want it tied to the geometry of the mass. So we already have the elevation information, right? We already have the different elevations of our levels right here. So what we can do is we can just plug this guy into the elevation. And then what we want is a name. Now, you could type in, and I'll do it really quick. Actually, let me grab a string. Remember, a string is a word value. So just type in level. Let's do that, right? So we can plug this in, and it will generate levels that have the name, level, and then level 1, level 2, level 3, level 4. Of course, that doesn't really work well, right? Because level 1 is technically this guy, and then technically the next one should be level 2, the next one should be level 3. So what if we just plug in level 1, right? Well, now that doesn't really do much because it just says the value. So what if we do it in parentheses? Oh, well, that kind of works, but, you know, never have I ever used level with the numeric value in parentheses. All right, so what can we do? Well, we can use a code block, just like we have the past couple times, to kind of crunch these two values together. Essentially, taking the here, I'll unplug this. What we're gonna want to do is take the name level and make sure that you do LVL or something other than the actual name level. Like I explained before, that's an actual command, which we don't want to copy. So LVL, and I want to just tack on a numeric value from 1 to however many levels we have in the project. And create a list of that we can then input into the name input that will generate a nice, clean naming structure to our levels. So what I can do is use a code block to create a series of values from, let's say, 1 to 13. So we'll type in 1, 13, and you notice how we don't have to add the third number like we have here. That's because Dynamo automatically defaults to 1 as the incremental step. If we did ... and 1, it'd do the same exact thing. But of course, if we change this to 3, then same thing. It would go from 1 to 13, increasing by 3, etc. But we want it to be 1. This is a very quick way to just get a series of numbers between the two values incrementally increasing by 1. I don't know if that was correct grammar. But, so we have the base value and the numeric values that we want to add to each other. So what we can do is just create a simple code block, name plus number, right? So what this does is it takes the name and it adds that value to whatever input into the number. And ta-da! Well, actually here, we're missing a space. So all you gotta do is go into the string, hit the space bar. That has a nice space. All right, so now that we have a really nice clean list of names for our levels, we can just plug that into here. Generate the list of levels. Now you can see that since there is a numeric value already within the names that we input, Dynamo doesn't put in any kind of numeric naming convention as well. So we get a nice clean list of level names. And we can see if we go into our Revit file that those also generate around the geometry in a standard form. And what we can do now is actually go in and delete the original levels. And we are now not necessarily stuck with, but we have the levels that correspond with the tower. Now, what a lot of you might realize, some of you smart, intelligent folk may realize, this isn't actually parametric to our series of parameters. You're right. You can do that. You can tie this series of lists to the levels, and all you would have to do is go in, change 13 to levels. It would give you an input into this code block, which you can then just plug the slider value into, and it would give you the nice same list here. But for some reason, and I tried a lot of different ways. I tried just rounding it. I tried doing it separately, and I tried a lot of different ways, okay? And I could not get rid of these 6 zeros for whatever reason. I do not know why Dynamo reads it like that. I don't know why it does that. But you can make it parametric. Of course, if we did increase the number of levels here, now that we have that tied, it would increase the amount of levels here. It would just have 6 decimal places behind it. And damn it, I do not like that. So for the purpose of right now, we will just shrink it down a little bit. And then actually, I guess that's fine for right now. We can just keep it parametric. It'll just be really odd, and our bosses will look at us like, why did you put 6 decimal places behind each level value? But that's fine. Getting back to the original point of why we were creating the levels, this is a tangent-heavy tutorial. Plug this in and create floors. All right, so it won't populate in your 3D view because it's a Revit element, but if you pan to your Revit project, it creates lightweight concrete on metal deck at the associated level and is tied to the geometry in which you created here. So if we go in and we go back to our script and we rotate, start rotating everything, and start to increase or decrease levels, or we start to decrease or increase the floor height, everything changes, right? That's the ultimate goal, is to create a fully parametric piece of architecture. So now that we have that done, what we can do is, now that we have some floors and we have some actual Revit geometry that we can use, I wanted to show you how you can actually start to create views and sheets within your Revit project from Dynamo, right? So have it completely parametrically create and start to set up your drawing set without having to do anything manually. So first, what we can do is we can create names and views, specifically floor plans. So we could type it in, but I'm just gonna go down to Revit group and then views, and then go down to floor plan view. And in this specific instance, we only have one option. So we will create a floor plan by level, plug a level in, right? And then if we go to our Revit project, go under floor plans, we now have all the floor plans based on levels. Now, of course, we could go in and specify specific levels we wanted floor plans created of, and then ones that we did not. But for right now, that's fine. All right, drag this back over. And then, let's see. So from these floor plans, you can also set the view. Now, floor plans coming from Dynamo, unfortunately, are going to be in the metric system because that's the easiest. Or, just kidding. Sorry, they'll be in whatever the default is. If we specify a scale within Dynamo, it will be a metric because that's that is the range of inputs that we have at our disposal. So we can go in and start to change the scale. Certain things. Oh boy, scale. I hate this search function. Scale. View set scale. There we go. So if we plug in the view, and then we plug in the floor. Just kidding, not the floor. We need a value. So, like I was saying, the scale is based on a more metric way of doing things. So instead of like an 1/8 inch or a 1/4 inch equals a foot, it's going to be a 1 to 100, 1 to 200, 1 to 50, 1 to 1. There are ways in which you can calculate what exactly an 1/8 of an inch equals a foot is in the metric system. But as of right now, I'm not going to. So I'll just use the typical 1 to 100. And that changes the value down here to 1 to 100. And then if you go in and you change that scale to, like, let's say 1 to 500, that's going to influence your scale. You can see that the elevation markers got larger. All right, the floor plans. All right, so after that absolute mess, let's go back to a 3D view. And last thing we'll do is we're going to build a Diagrid for this. Now, we are not going to do it like we did last class. We're not going to manually go in and select all of the individual floor faces and then divide all those one by one and connect each one by one. No. Since we already have the outlines of the floors in sequence in a nice ordered list, we can not necessarily cheat a little, but use our brain power to formulate a method in creating the Diagrid structure so that it's automatic. We can just use the one list, and it makes a nice parametric one that's not too heavy, and it gets a little bit more into list structure. So we have the outlines of the floors, and what we want is to divide the curves just like we did last class, to create some points that we can then connect with line work and then eventually associate columns and beams to. So what we can do is take the geometry, and we'll actually want these. We want two curves. We want a nice curvature that we can divide, and we'll divide the curve, split by points, or split by parameter. Nope, just kidding. Split by parameter. No, actually, sorry. Divide curve. Divide curve. Oops. Divide curve. And then we can just say, I don't know, 5 for right now. Actually, let's make that number slider so we can increase and decrease. We can increase and decrease the value. Make this a whole number, and let's just do 10 to start off. And we can reduce this down so it's not so hard. All right. So hit run, and we'll probably switch this to manual. And I'm going to go in and I'm going to freeze basically all of this so that it doesn't. I guess I can't freeze all of these, so I'll just freeze the two. Freeze view by level and freeze the title block. All right. Anyway, getting back to the divide curves. So what we want to do is we want to connect the bottom point to the top point. And we can do that by start and end point. Or line, excuse me, line by start end point. And go in. And use this as our start point. Now, what we need, so we currently have a list of points, and if we hit watch, select watch, all right, we have a series of points within a list structure of each corresponding curve. So every level, so this first list is the level itself. Then each corresponding list below that is the curves within the level. So this is the level. These are the two curves that create the ellipse. And these are the 5 points that are divided along that list, or 4 points, excuse me, that we specified here. Right, so we want to make sure, because this list structure is very important when we're going to begin to start setting up or start to connect the points together, right? So what we want to do is we want to take this set of points, the first level of points, and we want to connect them to the second level of points. And a really easy way to do that will essentially lead to a domino effect and connect the corresponding, the preceding level with the next level's points, is to essentially take this list of points and remove the first level completely, which will then basically remove this entire line of information and start the list with this line of information, subsequently connecting the first curve of points, which is coming from this list, and connecting it to the first line of code or line of data in this list, which will be the endpoint. Oh, and I know all of your eyes just glazed over, so I'll just do it, and hopefully visually seeing it will help. So what we want to do is remove the first item. So we want to remove item at index. The index will be 0, which will specify the first value in the list. Should have kept that watch open. Right, so if we look at the two lists together, this is the original list, this is the second list, right? So we've essentially gone in and removed this first line, which if we scroll over to the Z, you can see they're all 0, which signifies that they're at the first level. Then the second set is all at 13, that's the second level. Next one's 26, that's the third level, so on. What we've done is we've removed that first series of divisions at the first level and bumped it up here. So that when we plug it into the endpoint, it goes in and connects the first line of the first list with the first line of the second list, which is the second level, and then it does that with each corresponding level above that. I'm going to go in and unpreview the poly surface so that we can see this a little clearer. There we go. All right. And then just like with the last script that we developed, we need to do the opposite, right? If we want this to be a Diagrid, we need the other series of beams going the other way. And to do this, it's a little more complicated. And I know I'm probably going to go over a lot of y'all's heads because this is very nuanced and somewhat another language. But when we remove this item at index, right? When we remove the first item of the points, it takes the first item in the first list. So there's two sets of lists. There's the first list, which specifies which level this data is associated with, and then the second list, which specifies which curve at that level is being divided, and then the third is obviously the actual points themselves. So there's three substructures of lists within this node. To reverse the direction of the line work, to reverse the points being connected, so that instead of this point connecting to this point, it now is this point connecting to that point. What we need to do is do the same idea where we're removing the first point in the list. So all we got to do is essentially take this command, the remove item at the 0 index, but instead of removing the first larger item, the first item in the larger list, we need to go 3 levels down. We need to essentially do inception on the list. We need to go 3 levels down and remove the first point of this list of points. And then plug that in as our next start and end point. So to do that, we use a tool called list map. And list mapping, where is it? Map. It's called list.map. And this essentially takes a function and applies it over the elements of a list. And what you can use this for is if you take, let's say you take this function, remove item at index, you remove the actual list itself, and you plug this into the function, right? So this node is a function in itself. It's saying you're going to remove the first item of the input list. But instead of inputting a list into the remove item at index, you're mapping it to, and essentially applying this function to the second level of lists, right? So if we plug in the list directly to the function, it's going to do whatever function you plug it in to the first sublist. If you plug this in to the list map, it applies it to the second layer, the second level of sublists, right? So now, instead of removing the first larger item of the list, it's gone in and removed the second substructure. So if we go in, we can find that it's actually removed this guy from every list in here. Of course, we don't need that, right? We need to remove the first point, right? So we need to go one step further, one more level down into the list structure and remove that point. So what we need to do is actually just copy and paste the list map, plug this in, and then plug the points into the second list map. And then what we're essentially saying is we're removing the first item, not from the first level, not from the second level, but the third level of substructure lists within the original list itself. And if we go in and look, you can see that it's removed the first point in each sublist, so that if we copy and paste the line, and we plug it into the top guy, we now get a nice diamond panel. So I know that was somewhat convoluted and I probably repeated myself 30 times, but ultimately this is how you set up this is getting kind of into the weeds on list structures and how you control them within Dynamo to better control your designs and your scripts. And so what we can do is we can apply columns just like we did last time. So we can just type in column. Oh, nope, sorry. Structural column types, there we go. And then column by curve. And then we can use our levels from the previous part of the script in our level so that each column has its corresponding level, which is pretty nice. And then just like last time, we'll load in the insert load family. We'll insert the column and the beam because we will also be doing a beam here, which it can be found on the files folder under Dynamo rotating tower, I think, something like that. Where am I going? Documents, University, Dynamo. Open this guy. So that's the beam, and then I need to grab the column as well from the Villa Savoie. Alright, so I've loaded those two in. So now it should populate under here. And then plug that in. Dun, 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 and plug this guy in. And if we go to our Revit file, you can see we've started to create this structure. Now, of course, it's not very elegant. So let's change this to a 6-inch column. All right, it's a little better. Actually, kind of looks a little weak now. Let's try 8 inches and call it a day. All right, and then from here, what we can do is we can create beams. So we can create a horizontal beam in between the nodes at each floor plate. Now we cannot use. Well, we'll try. Let's try. Nah, it's not gonna let us. It might let us. Anyway, let's try and create a beam. So we'll type in beam. It'll ask beam by curve. So same thing. It's gonna ask for the level that you want the beam associated with. Then it'll want the curves. Now, what I'm going to try and do is do a curved curve. And then, let's see, beam, does it give beam? No, it doesn't. So I'll have to do family types again. And then, what is this freaking thing called? What is the beam specifically called? It's called HSS round structural tubing. Okay, so we can scroll right to it. All right, plug that in. Oh, and I have something selected. Yep. Hey, look at that. It gave us round tubes. Wasn't sure that was going to work. All right. Now, if you want to facet the tube, the intermediate structure, you can. That's definitely a possibility. All you'd have to do, is essentially go in, do a poly curve by points. And instead, poly curve by points, and then where is the divide curve? There we go. Plug in the divide points, and then plug that into your curve. Probably can't do it. Oop. Need to explode those into single curves. So explode geometry. There we go. So in this case, then you have actual broken beams in your project. And then now we can manipulate this, edit this however we want. I'm gonna hide the points, preview the points, and I'm gonna preview the split by parameter and the rotate. All right. So now if we zoom out a little bit, and let's turn back on the poly surface, give us some geometry. Now we can go in and want to turn this to manual before we start playing with stuff, but we can increase the number of levels, the height of the levels, the radius of the two, the ellipses, and then the rotation specifically. And if we hit run, this entire thing is set up parametrically so that the entire form, the structure, the floor plates, the sheets, the views, all correspond and update accordingly to the input parameters. It's going to take a long time because it has a lot of different parameters. You can unjoin that, that's fine. And it's completely manipulatable and updates your geometry. So, this was a long one. So, this will also bleed into your assignment. I'll essentially want a couple different designs based on different parameters that you input. And from that, then I want you to apply a adaptive component like we did in the last assignment, and show a couple different iterations of that. Totally understand that this is going to be heavy for a lot of your computers, so just do the best that you can. If you need to refine, if you need to shrink down, you need to remove the amount of levels, if you need to, remove or, really simplify the model, that's okay. Just do that and then specify in the submission that you were having trouble, and that's why your design is a little more simplified. All right. Thanks, guys.